Section 6.5. Lengths of curves, also known as arc length. As you read through the section, you come up with a formula that says the arc length is equal to the integral from a to b, the square root of 1 plus the derivative of x, quantity squared dx. And this is if you're talking about a function using x's. If you're using y's in the equation, it changes a little bit. The equation becomes, and they use c to d this time, not to confuse it with the x values. And this would be the square root of 1 plus, and this function is in terms of y's squared dy. So it's the same formula, you're just using y's, which means that your c and your d have to be y values instead of x values. So let's look at example 1. Find the length of the arc length of the curve f of x equals x to the 3 halves between 0 and 4. Okay. If you graph it between 0 and 4, it just looks like this. And it's all in x's, so we are going to integrate from 0 to 4 the square root of, now I need the derivative, f prime of x is going to be 3 halves x to the 1 half. So here I'm going to have 1 plus 3 halves x to the 1 half quantity squared dx, which turns into 1 plus 9/4 x dx. Now this would be a u substitution, and we would let u be the 1 plus 9/4 x, and so the du would be 9/4 dx. And you have to change the values out. So when x is 4, u is going to be 1 plus 9/4 times 4, 10. So up here's a 10. And when x is 0, u is going to be 1 plus 9/4 times 0, or 1. So there's my boundaries. This becomes 1 plus 9/4 x is my u to the 1 half. Now I've got to fill in my missing pieces. I have, this is my u. My du is supposed to be 9/4 dx, so I need to put a 9/4 in here, which means I need to put a 4/9 on the outside. So this turns into a 4/9 outside the integral. And then this piece right here is your du. So we have 4/9. How do you integrate? You raise the power and you flip it in front. And now you're going to plug and chug your way through here. This is going to give me 8/27 to start. And then I'm going to have the square root of 10 cubed minus square root of 1 cubed, which just gives me 8/27. 10 to the 3 halves, I can't really do anything with that, minus 1. Putting that in my calculator, I get about 9.1, and these would be units. It's whatever your measure of length is. Let's try example 2. Example 2 says f of x is x cubed plus 1/12x. They want the arc length from 1 half to 2. If you graphed it, it has a fairly smooth curve, but it looks a little weird. It comes down, it has a pretty sharp turn, and then it heads back up. And they're starting it at 1 half because this curve, it can't be 0. You can't stick an x as 0, so you can't start the curve at 0 when you're doing your arc length because you never touch 0. So they started at 1 half. So the length is going to be the integral from 1 half to 2. Oh, I need a derivative. the derivative is going to be 3x squared plus 1/12. That's x to the negative 1, so it's going to be negative 1x to the negative 2. So here in my square root, I have 1 plus, oh, this is going to be a lovely mess, 3x squared minus 1 over 12x squared, quantity squared dx. I'm going to take a little detour over to the right side here, and I'm going to do the squaring of this nonsense. 3x squared minus 1 over 12x squared, quantity squared. Squaring the first is 9x to the fourth. Multiplying the two together, the x squares will cancel. We'll get a negative 1/4. We double it, so we'll get a negative 1/2. And if you can't do that in your head, write it down twice and FOIL it. Then you're going to get a 1 over 144x to the fourth. Now, when I put that together with the 1 I've got there, I have the 9x to the fourth. The 1 and the negative 1/2 is plus a half, and then 1 over 144x to the fourth. Now this factors. This is a perfect square trinomial, and it looks very closely similar to the one we just finished foiling out. The only difference is it has a positive 1/2 instead of a negative 1/2, which means that this turns into 3x squared plus 1 over 12x squared, quantity squared, which would then pull the square and the square root cancels. And when I write this, I'm going to write it as 1/12 x to the negative 2, so I can integrate. So now I raise the power. I flip it in front, so that's going to make it, the 3's cancel. When I raise the power and I flip it in front, I get that. Oh, I lost the 1. And I'm evaluating from 1/2 to 2. So I get 2 cubed is 8 minus, stick a 2 in there, I get 1 over 24, minus in parentheses, 1/2 cubed is 1/8, minus 1/2 in there becomes 2, it's flipped over, so 1/6. And if I do this into 24ths, it's a negative 1 over 24, with the negative in front is positive, then it cancels, and so I just get 8. That came out kind of nice to be how messy it was. All right, that finishes example 2, and this would be 8 units. Okay, we're still in section 6.5. We're doing example 3. It says, consider the segment of the parabola f of x equals x squared on the interval 0 to 2. Write the integral for the length of the curve. That's part A. All right, so I need a derivative. The derivative is 2x. The length would be 0 to 2 square root 1 plus 2x quantity squared dx, so 0 to 2, square root of 1 plus 4x squared dx. That was part A. Part B wants us to use our calculator. Now you're using a TI-84 or 83. Okay, depending on the operating system, it's going to look a little different on your calculators, but you're going to pick the math button, which is right below the alpha button. And then you're going to scroll down and find the one that says FNINT parenthesis. If you've got a newer operating system, it might actually have an integral sign there for you to work with. And you pick that. If it comes up with the integral sign, you just type it in exactly as you see the problem that we just did in Part A. But if you're typing it in your calculator and it has fn integral, it's a function integral, you have to put it in a little oddly. So the first thing you do is you put in the equation, so you're going to get your square root button, 1 plus 4x squared, comma, then the x, then a 0, and then a 2, and then close it. You have to tell it what the variable is. Okay, and you have to tell it the x because it needs to know what variable you're using. So it looks a little weird. When you put it in your calculator, you should get 4.647 if I round it to 3 decimal places. If you have the new operating system, you're going to get these little boxes, and you're just going to fill it in. Looks just like the normal integral problem. If you're running the operating system that has the integral sign, you can also find that by doing alpha, and it's one of the F keys, F1, F2, F3, the buttons at the top, has the integral sign. It's called a numeric integral. So either way it works. If you're using a TI-83, the first method, by going to math, is the only way that's going to work because a TI-83 can't be updated. So you have to put in the function integral with the extra comma for the x. All right, example 4. This one says y equals x to the 2/3, and you want it between x is 0 and x is 8. Now when you draw this picture, it goes like this, and this is 8. If I stick 8 in there, the cube root of 8 is 2 squared is 4, and this one is 0, 0. Okay. The derivative for this is going to be 2/3 x to the negative 1/3, which is going to have a problem at x equals 0 because you can't stick 0 in the denominator. So we need to describe the curve with y as the independent variable. So we're going to switch it around. And we're going to solve this for y, for x. So we're going to raise both sides to the 3/2. And then that gives me x equals y to the 3/2. Now when you take that derivative, x prime would be 3/2 y to the 1/2. Now we don't have an issue, because now if you stick in y is 0, it's okay. We can take the square root of 0. So if we put in the length formula, we have to use the square root of integral 1 plus 3 over 2 y to the 1/2 squared dy. Now be careful on your boundaries. You're using y's, so you have to use the y's, so it's 0 to 4. Now if you look closely at that one, we did that exact same question in example 1, only it was with x's. So you'd follow the same exact procedure I did in the first example, doing your u substitution. I'm not going to redo it here, but you have the 1 plus 9/4 y dy, and you're going to let your u substitution be the 1 plus 9/4, and so your du is going to be 9/4 dy, and so on, swapping out your y's for your u's. And the answer we got when we did it on the first example was 9.1 units. So it was beneficial to us for this one to solve it for the x instead of the y, because when you do the integral from here, you can't plug in the 0 for the x because that x to the negative 1/3 is on the bottom. So that's not going to work. So that's why you switch it around. This concludes 6.5.